All right, guys, this is your video for 2-1 and 2-3. 2-1 and 2-3 kind of get mixed together, so we have the video together, but we're going to do it in two parts, so it's not too much all in one day. So this is the first part. There are two different styles of reasoning, two different ways that you can think about how to solve a problem, and those two different ways are called inductive and deductive reasoning. And so we'll talk about the difference between those. So first I have an example for you. So this little area right here is just for you to make a summary about my example so that you can remember it a couple weeks from now. So pretend that Ian is out watching the tennis team and he sees one of the tennis players throw the ball up for their serve, and then he notices that the ball comes down and hits the ground and they miss their serve. So then he watches them again and they throw the ball up and it comes back down. So then Ian, after seeing this several times, he surmises that, well, when you throw a tennis ball up in the air, well, it must come back down. So Ian is watching this actually happen. The tennis ball is going up and it's coming back down. And based on his observations, he notices a pattern and he says, hey, this must be what's going on. David, on the other hand, poor David. David lives in a bubble. David is not allowed outside, and he has never actually seen a tennis ball. But what David does have is a physics book. So in David's physics book, he reads about gravity and about Newton's laws, and so he surmises, without ever even having seen a tennis ball, that if you were to throw the tennis ball up or throw any object up in the air, that it would have to come back down. So what we can learn from this is that Ian is using inductive reasoning. Excuse the handwriting. And David is using deductive reasoning. Okay, so see how beautifully that works out? Ian is inductive, David is deductive with the D's there. So hopefully that will help you remember. Okay, so we're going to get into that a little bit more. So I want you to read your vocabulary grid, read the definition of inductive reasoning, conjecture, and deductive reasoning. Okay, any inductive argument, again, with the handwriting, can also be expressed deductively, and any deductive argument I'm still learning this new app. Y'all have to forgive me. Any deductive argument can also be expressed inductively. And all that really says is a problem is a problem. How I choose to solve that problem, whether I choose to solve that problem, whether I choose to solve that problem using inductive reasoning, meaning I figure it out by myself, like I see a pattern, I notice something, or whether I choose to solve that problem deductively, meaning I read it in a book, somebody tells me that that's the facts, it doesn't matter, the problem still gets solved. So any problem can be solved inductively or deductively, depending on the situation, okay? All right, so let's look here. All right, which of the following claims would be expressed using inductive reasoning? So remember, we just talked about inductive reasoning is noticing a pattern, visualizing something for yourself, or an observation. So, here we go. I can't get myself straight. Your first quiz grade usually indicates how well you will do in the course. So for me, that's a strong indication of inductive reasoning. Usually means it's not a hard fact, it's not a rule, and then indicates, noticing that it's, again, not a fact, that this is a pattern that I've observed based on my behavior in the past of taking courses. Okay? B, the final exam accounts for 30% of your course grade. C, late papers are not accepted. Or D, Gravity's Rainbow is a required reading. All of these things are things that are probably written in your syllabus. So they are written as fact. They're something that you could read. It is not something that you are expected to figure out on your own. It's something that is told to you. So since that is something that's told to you, you read it, that is deductive reasoning. So the one that's inductive is the one you figure out by yourself, which would be your quiz grade. Okay. Which of the following claims could be expressed by deductive reasoning? So now we are looking for deductive reasoning, meaning it's a fact, it's a rule, it's a law, it's a definition, it's something like that. All right, California's population growth rate slowed last year. So maybe that's something that I figured out myself. I just saw that there were less people. I could have read that somewhere, so I'm not sure about that one. We're going to hold on to that one. California residents appreciate good weather. Okay, here's some words indicating inductive reasoning here. Appreciate is a matter of opinion, as is good weather. What's good weather to me might not be good weather to you. What I notice is somebody being appreciative, you may not notice. So that is inductive reasoning. That would be someone observing people. So we know we don't want that one. C, California residents are residents of the United States. Well, that's the definition of what a state is. Residents of one state are residents of the United States. So that is a definition. That's a fact. You could read about that in a textbook. So for now, I'm going to say that C is better than A because C is a hard definition, a hard fact. More cars are registered in California than any other state. That's kind of the same thing as A. I could go and look up the registrations and read about that as a fact, or I could notice the license plates as I was reading, as I was traveling. So A and D are iffy, but C is your good one. C is for sure a definition. So I always go with the sure thing more than just the iffies. Okay, example 3. Why don't y'all pause and try to do example 3 and then come back with me and let's see if you got it right. Okay, so pause right here. All right, so we are looking for a deductive conclusion, which means a hard fact. So A, when I see things like mild winter, previously, those are indications of inductive. The cherry crop needs at least a week of freezing temperatures for best results, and this winter the temperature stayed several degrees above freezing. I'm going to hold on to that. What the cherry crops need are probably listed like in their documents for if you buy a cherry tree in the little brochure or the little tag that comes with the tree. It'll tell you what they need, and then I can, of course, document the temperature and go look that up. So I'm going to hold on to that one. Primo noticed whenever the skiing was good. So again, these are indications of inductive. These are observations, and they are opinions about what weather is good. Not since 1972 have I seen. So again, that's an observation. So for me, B is the clear-cut winner. It's the only one that's not based on observations or opinions. Okay, inductive reasoning is based on patterns and past experience. Notice that alliteration there, look at that, we're being English teachers, will help you remember inductive reasoning, patterns and past experiences. Okay, so what we're going to do now is we are going to identify patterns because that is a type of inductive reasoning. So it says find the next item in the pattern and identify the pattern. When you write a sentence identifying the pattern, that's like a conjecture. So you already read about conjecture. So A, January, March, May. Well, as soon as I read January, March, I realize that February is left out. Then they get to March, and then they leave out April, and then they get to May. So then after May, they're going to leave out June, and what would be next would be July. So July would be the next item in the pattern. And to identify the pattern is every other month. Okay, 7, 14, 21, 28. So you can look at this either way. You can say, okay, they're adding 7 each time. And so then you can add 7 and you would know you would be at 35. Or you can say these are the multiples of 7. This is 7 times 1, 7 times 2, 7 times 3, 7 times 4, and this is 7 times 5. Whoopsies. So either way that you figured out the pattern, that's what you're going to write about the pattern. So you could either say the next term is adding 7 to the previous term, or you can say the terms are increasing multiples of 7. You would want to make sure that they're in order. You would say something about they're in order, because if I just said multiples of 7, you could write your pattern in any order. 7, 28, 14, these are multiples of 7, but our pattern is special because they're in increasing order. So either way, you wanted to say that increasing multiples of 7, or you can say the next pattern is 7 is an addition of 7 from the previous term. Either way, you'd be right. All right, y'all pause and do C. Okay, so with C, I'm going to look at the tip of this, and I'm going to notice what's happening to it. So it's pointing towards the top, now the right, now the bottom. So my final answer would be well, mine's very pretty, so I hope you can live up to that expectation. So here it's pointing to the left. So I would say that this triangle is rotating 90 degrees clockwise. Okay, what's it doing? It's rotating by how much and which direction. So the point of a conjecture is that anybody could read your conjecture and be able to follow the pattern. If your conjecture is wishy-washy, if it doesn't make full sense, then it's not a good conjecture. You have to imagine that somebody who can't even see the pattern is reading your conjecture, and they could be able to create the pattern based just solely on your conjecture. Okay, let's see here. Okay, example 5, make a conjecture. So if you don't have a pattern listed there, if you're just expected to finish a sentence, you should make up your own example. So A says the sum of two positive numbers. So I'm going to make up several examples of adding two positive numbers together, and I'm going to see what happens. So let's say like 2 plus 4 is 6. So those are two even numbers. What about 5 plus 3? Two odd numbers. What about 1 plus 1? What about the same number? So I'm going to have a lot of different examples, but they all lead me to the same conclusion. The sum of two positive numbers is positive. Okay, y'all try B really quickly and then come back and unpause when you get B done. Okay, so for B, you should have got the number of line segments formed by 4 points, no 3 of which collinear is 6. So the easiest picture to draw is just the box with the X in it. Okay, steps to inductive reasoning. First, we are going to look for a pattern. Then we are going to make a conjecture. And we just saw those two steps used in the last two examples. And then we are either going to prove our conjecture if it's true, or if it's false, we will find a counterexample. Okay, so we already did look for a pattern and make a conjecture. Those are the last couple examples. So prove the conjecture is true. That's what we're going to do at the end of next week. That's the end of the chapter. But for now, we're going to work on finding a counterexample if it's false. Okay, so example 6 says every dog is a poodle. Now, of course, you know every dog is not a poodle, but a counterexample is a very specific example that goes against the conjecture. So I'm going to say my dog, Roxy, because see, that's very specific. It's my dog and her name is Roxy, so I'm being a very specific example. My dog, Roxy, is a pug. Okay, so I didn't just say there are pugs, and I didn't just say not all dogs are poodles. I gave you a specific example about a dog that is not a poodle. Okay. So you try this one. Two complementary angles are not congruent. Pause and try to come up with a counterexample. Okay, so my counterexample, the measure of angle A is 45 degrees and the measure of angle B is 45 degrees. So I can see that 45 and 45 are congruent, and 45 plus 45 is 90, so they are also complementary. So I have found two complementary angles that are congruent, so that disproves my conjecture. So again, I want to be very specific. I want a specific example. Here's my specific example, A and B. I didn't just say, hey, it could happen, or 45 and 45. I gave you a specific example. Okay, this is the end of the video for the first half. You will watch the second half and we'll do all of this tomorrow night. But tomorrow in class, we'll go back over all this stuff, inductive versus deductive patterns, conjectures. So we'll see you tomorrow.